Example number 7. Page number 216. Use principle of induction to prove that 1 plus 3 over 1 into 1 plus 5 over 4 into 1 plus 7 over 9 and so on. Solution. We have to prove that 1 plus 3 over 1 1 plus 3 over 1 1 plus 5 over 4 into 1 plus 7 over 9 so on 1 plus 2n plus 1 over n square is equal to n plus 1 whole square. Now for n is equal to 1, for n is equal to 1, left hand side is equal to first term, what is first term here? 1 plus 3 over 1 is equal to 1 plus 3 is equal to 4. And right hand side n plus 1 whole square. If we put n is equal to 1, 1 plus 1 square is equal to 2 square is equal to 4. Therefore, result is true for n is equal to 1. Therefore, result 1 is true for n is equal to 1. Assume that result 1 is true for n is equal to k. Assume that result 1 is true for n is equal to k. Therefore, 1 plus 3 over 1 into 1 plus 5 over 4 into 1 plus 7 over 9 so on 1 plus 2k plus 1 over k square is equal to k plus 1 whole square. Now what we will add or multiply? Their terms are multiplied by each other, so we will multiply the next term. What is that term? Multiply both terms, multiply both sides by
2 plus 2k plus 1 by k square.
1 plus 2k plus 1 1 1 plus 2 into k plus 1 plus 1 over k plus 1
whole square.
whole square. This we will add over 1 plus 2k plus 2 plus 1 3 over k plus 1. This we will add multiply both sides by 1 plus 2k plus 3 k plus 1 cube and we get 1 plus 3 over 7 1 plus 5 over 4 1 plus 7 over 9 so on 1 plus 2k plus 1 k square
K plus 1 cube.
K plus 1 cube. K plus 1 square. Here square. K plus 1 square. K plus 1 square. Okay. 1 plus 2k plus 3 over k plus
K
1
plus 1
is
square.
equal to k plus 1 square multiply by both side we will multiply 2k
Plus
1 plus 2k
k
plus 3 over k
K
plus
plus 1
1 comes square.
square. Now what should be our answer?
K plus
K
2 whole square
plus 1 plus 1
plus 1
whole square is equal to k plus
K
2
plus 2
whole
square.
square. This is our answer. It should be k plus 1 square. Now take LCM. K plus 1 whole square is LCM. Multiply k plus 1 square is equal to 1 with 1, k plus 1 whole square. Plus multiply these two terms, cross multiplication, k plus 1, 3. Now this k plus 1 square cut by, divide by k plus 1 whole square. Open bracket, k square, 2k plus 1 plus 2k plus
Plus 3
3. K square plus
plus 4k
4k plus 4.
4
This is k square
plus 2k
2 into 2k plus 2 square. A square plus 2ab plus b square, which is equal to k plus a plus b whole square. This is k plus 1 plus 1 whole square. Therefore, result is true for n is equal to k. Therefore, result 1 is 2, 4 and is equal to k plus 1. Also, result 1 is true for n is equal to k. Also, result is true for n is equal to 1. Therefore, by method of induction, result is true for
all and belongs to natural number.
n belongs to
Natural.
now example number 8. Take its screenshot.
Done, sir.
Now example number 8. Use principle of mathematical induction to prove that 41 power n minus 14 power n is a multiple of 27 for all n belongs to n. In statement there is multiply, multiple or divisible by, then we should show the factor. That number should be factor of the given statement, the given number. In this question, we will show 27 is a factor of the given statement, the given number. Solution Pn. Take Pn is equal to 41 power. Let we assume Pn. And P is function of n. 41 power n minus 14 over 14 power n is a multiple of 27. In all steps we will show 27 is it's a factor, it's one factor. Okay, now for n is equal to 1, p1 is equal to 41
41
1
minus 14.
minus 41 power 1, 41 minus 14 is equal to
27.
7 minus 27. Therefore Pn is multiple of 27. Therefore result is 2 for n is equal to 1.
1.
For n is equal to 1. Assume that result is true for n is equal to k. Assume that result is true for n is equal to k.
Okay.
If result is true for n is equal to k, therefore pk is equal to 41k
K
minus
plus
14
14
14k.
power k.
power k is a multiple of 27. 27. Let if we solve right hand side, then there will be some answer. 41 power k 14 power k is equal to 27m. Okay, because pk is multiple of 27, therefore 27 is a factor of answer. When we will solve right hand side, there will be some answer. That answer is m multiplied by 27, because 27 is a multiple of
People.
answer. We can write it as 41 power k is equal to 27m plus 14k. Okay,
Yes.
this is number 1. Now pk plus 1 is equal to 41 power
41 k plus 1
plus 1 minus 14
minus
power
14 k plus
k plus 1. 41k, we can write it as 41 into 41, 14k into 14. Now put the value of 41k from 1, 27m
minus 14 power k
plus
plus
27m plus 14k power k multiply by 41 minus 14 power k into 14. Now multiply with 41, 27 into 41 into m plus 14k into 41 minus 14k into
k
14. Take 14 power k common. 14 power k common. 41 minus 14 plus 27 into 41 m.
m
27 14k plus 27
41 m
41 m. Now 27 is common. 14k plus 41. Therefore 27 is a multiple of given answer, which is multiple of 27. Therefore, result is true for n is equal to k plus 1. Therefore, multiple, factor, all things are same. Or divisible by. In all these types question, we will show that number is multiple of that number is a factor of the answer, given statement's answer. Result is 2, 4, n is equal to k plus 1. Also, result is 2, 4,
n is equal to 1.
n is equal to 1. Also,
K.
result is 2. N is equal to 1. Therefore, by mathematical induction, by method of induction, a spaceless therefore by method of induction result 1 is 1. We do not choose 1. Result is true for all
All n.
is to n. Now example number 9. Take its screenshot.
Done.
Example number 9. Page number 18. Use principle of mathematical induction to prove that x power 2n minus y power 2n is divisible by x plus 1 for all n belongs to n. In this question, we will show x plus 1 is x square 2n minus x power 2n minus y power 2n is divisible by x plus 1. That is, we will show x plus y is a factor of the given answer, given question's answer. Let Pn is equal to x power 2n minus y power 2n. For n is equal to 1, Pn is equal to x power 2 y power 2. A square minus b square is equal to hello.
Hello. Hello.
A square minus b square is equal to
A plus b, a minus b.
a minus b, a plus b, which is divisible by x plus 1, which is divisible by x plus 1. Okay.
Yes.
Yes.
X plus y, which is divisible by
X plus
y. Therefore, result is true for n is equal to 1. Therefore, result is true for n is equal to 1. Assume that result is true for n is equal to
n
k.
is equal to 1.
N is equal to 1. N is equal to k.
N is equal to K.
N is equal to k. K.
K.
Therefore, Pk is equal to x power 2k
2k
minus by
plus
power
y power 2k
2k is divisible by
x plus 1
x plus y.
Y.
If it is divisible by x plus y, then we can write let x in power 2k minus by power 2k is equal to m into x plus y. In answer, there will be x plus y is a factor. M is where m is an integer. There will be any answer when we will solve this number or this factor where m is integer.
any integer.
Now p k plus 1 is equal to, or we can write it x power 2k is equal to m into x plus by plus by power 2k. This is our first number. Now pk plus 1 is equal to pk plus 1 is equal to x
X
power 2 into
2k plus 1
k plus 1 minus
minus
by
y power
k
2
plus
into
1.
k
K
plus
plus
1.
1.
Now we will again show that x plus y is a factor of this calculation or questions answer. Now we can write it 2 x power 2k plus 2 x power 2k plus 2
Plus 2
by power
minus y power
k
2k
plus 2, or we can write x power 2k into x power 2 pi power 2k into pi square. Put value of x power 2k from 1. X power 2k is equal to m into x plus
x plus
pi
y
plus pi in power
by 2k
2k multiply by x square pi into pi power 2k into pi square. Now multiply it with x square m into x square x plus
Yeah.
pi x square pi power 2k minus pi power 2k into pi square
Okay.
x plus pi 2m into x square.
Okay.
What is common? These two terms. In these two terms, pi power 2k is common. X square minus pi square.
Y
X square pi power 2k. Here again a square minus b square is equal to a minus b, a plus
a plus b.
e. Now we can take x plus y as common. X plus y common. M into x square x minus y into pi power. Okay, again x plus y is a factor. Therefore, this is divisible by x plus y. We can divide it by x plus y or not. Answer, can be divided by x plus y?
Yes.
which is divisible by x plus y. Divisible by x plus y. Therefore, result is true for n is equal to. Therefore, 2 for n is equal to k plus
K plus 1.
also result is true for n is equal to 1. Therefore, by method of induction, therefore, by method of induction, result is true for all n belongs to n. Now, example number 10. Take screenshot.
Done, sir.
Example number 10. Use principle of mathematical induction to prove that n into n plus 1 into n plus 5 is a multiple of 3. This question, we will show the result is multiple by 3. Again, we will show 3 is a factor. Let En is equal to n into n plus 1 into n plus
5.
5. And for n is equal to 1, P1 is equal to 1 into 1 plus 1 to 1 plus 5. 1 multiplied by 2 multiplied by 6. 1 multiplied by 2 multiplied by 6, 12, which is a multiple of 3. Okay. 3 into 4, which is a multiple of 3, which is a multiple of 3. Visual y or factor or multiple, all things are same. Therefore, result is true for n is equal to 1.
1.
It is true for n is equal to 1.
1.
Now assume that result is true for n is equal to k. Assume that result is true for n is equal to k. Therefore, pk is equal to
K plus 1. K plus
K.
1.
K plus
K plus 1.
K plus 5.
K plus 5. Because this is multiple of 3, therefore we can write it. Let k into k plus 1 and k plus 5. Because it is a multiple of 3, Therefore 3 into some else answer, say m. And we will solve these factors. Then we will get 3 into m or any other number, which here m is an integer. Understand this step?
Yes.
Where as we multiply 1 into 3 into 4, 12. 3 into some number. It may be 4, it may be any other number. We assume it is m. Here m is any
Teacher.
Any integer.
m is any integer. M used for general term. Now pk plus 1 is equal to
K plus 1.
k plus 1,
K plus 1 plus 1.
k plus 1 plus 1, 2, and k plus 1 plus
K
5,
plus 6.
6. And what should be our answer? K into k plus 2, k plus 6. No. We will show M3 is a multiple of answer. Now write it as k plus 1, k plus 2, k plus 5 plus 1. Same thing.
Yeah.
Now multiply k plus 2, k, multiply k plus 2 with remaining terms, k plus 5 plus 1.
1.
Here we will multiply k by first term, or take one step more, k into k plus 1 into k plus
K
5
plus 1.
plus k plus 1. Now multiply by k plus 1,
K plus 5.
5 plus
5.
k
K plus 1.
plus 1. Now multiply by 2 into k plus 1 into k plus 5 plus 2 k plus 1. Okay.
Yes.
We need this number, this term in this answer, k into k plus 1 into k plus 5, k into k plus 1 into k plus 5. We can put it 3m is equal to 3m
Yeah.
plus
K plus 1.
or k plus 1 is common in all terms. K plus 1 is common. k into 2k plus 1 into 2. Okay. K plus 1 common, k plus 5. K plus 5. K plus 1. K into 2 k plus 5 plus 2. 3m plus k plus 1 k into 2k
K
plus 10
plus 10
plus 2.
plus
2.
3k plus k plus 1 into
K plus
k plus
3K
12.
12.
3k plus 3 is common. 3k plus 1 into k plus 4.
4.
Now 3 is common. K plus 1 plus 4, which is multiple of 3. 3 is a factor, therefore number is the given answer is multiple of 3, which is a multiple of 3. Okay, therefore result is true for n is equal to k plus 1. Also result is true for n is equal to k. Here they write one more, they add one more line. Result is true for n is equal to k plus 1 because if result is true for n is equal to k, then it is also true for n is equal to k plus 1, because if result is true for n is equal to k, then it is also true for n is equal to k plus 1.
K plus 1.
One more line is added here. Therefore, by mathematical induction, by method of induction, result is for all n belongs to n. Okay. Now example number 11. Take the screenshot.
Done, sir.
Now example number 11 is to 19. Use method of induction to prove that 1 plus x whole power n is greater than 1 plus nx for x is greater than -1 and for all natural numbers n. We have to prove that. To prove that 1 plus x power n 1 plus x power n is greater than equal to 1 plus nx for n is natural number. N is natural number mean n is greater than equal to 1 and x is greater than minus 1. Two conditions are given. One is n is natural number mean n is greater than equal to 1, and second is x is greater than minus 1.
Minus 1.
X should be positive. Zero or positive. For n is equal to 1. For n is equal to 1, 1 becomes one becomes 1 plus 1 sorry 1 plus x power 1 is greater than equal to 1 plus 1 into x. 1 plus x is greater than 1 plus x, which is true. Which is true always. 1 plus x is greater than or equal to 1 plus x.
Equal to 1 plus 1.
Which is always true. Which is always true. Therefore, result is true for n is equal to 1. Result 1 is true for n is equal to 1. Assume that result is true for n is equal to k. Assume that result 1 true for n is equal to k. If result is true for n is equal to k, therefore 1 plus x power
K
is greater than equal to 1 plus
1 plus
ax.
kx.
Now one condition is given here. Now x is greater than minus 1. Therefore, this implies x plus 1 is greater than 0. Condition is given in the statement. We will use it further process. Therefore, multiply both sides of 2 by 1 plus x. Multiply to make k plus 1. What we will do in this step? What changes will there to write next term k plus 1? We will multiply it k plus 1. Okay.
Yes.
Multiply both term two. This is not, this is 2. Both term of 2 by x plus 1. 1 plus x power k multiply by 1 plus x or x plus 1, same thing. 1 plus x k into x plus 1. Now this become 1 plus x power k plus 1 is greater than. Now solve this. X plus 1 multiply by 1, x plus 1 plus k
Kx square
here plus
kx.
Plus k.
ax, which is greater than x plus 1 plus kx plus k
Yeah.
x square. Now compare with the given statement 1 plus x power k plus 1 in place of n greater than 1 plus we can write it as x plus 1 plus kx plus kx
Yeah.
here greater than 1 plus x is common k plus 1 x plus k x square. Now we can write if 1 plus x power k plus 1 is greater than this, then this will also be greater than 1 plus k plus 1 x. Okay, this
Yes.
number is greater, this number is greater than 1 plus k plus 1. If 1 plus x power k plus 1 is greater than this is greater number and this is smaller number. If 1 plus x plus power k plus 1 is greater than this is also greater than 1 plus k plus 1
K
x.
plus 1 x.
X. Because k x square is greater than equal to 0. Either it will be 0 or it will be greater than 0. Why greater than 0? Why it should not be negative? Why it will not be a negative?
Square.
Because x square. If we put x minus 1 square positive 1. If we put minus 2 multiplied by minus 2 is 4. Okay, it means this result will not reduce. This term will not reduce. Either x k square is either values for either value. Therefore, result is 2 4. One is 2 4 n is equal to k plus 1. Also, result is 2 4 n is equal to 1. Therefore, a method of induction result two 4 r n belongs to n. Take screenshot.
Yes, sir.
Now last example number 12. Show by method of induction that 1 plus 2 plus 3 plus so on n is less than 1 over 8 into 2n plus 1 whole square for all n belongs to n natural number. Example number 12. We have to prove that we have to prove that 1 plus 2 plus 3 so on plus n is less than 1 over 8 2n plus 1 whole square for all n or for all natural numbers. This is first, and for n is equal to 1, left hand side is equal to 1 and right hand side is equal to 1 over 8
8 2 1 plus 1 का होल स्क्वायर 2
2 into 1 2 plus 1 square. We can write 1 over 8.
into 9
These are 9 or 9 over 8. And
8
1 is less than, that we can write left hand side is less than right hand side, because 1 is less than 9 over 8. When we will divide 9 by 8, what will be our answer? 8 1 ka 8 0 8 1 8 less than 1. 1 is less than 1 point something. Okay.
Yes.
Which is true. Therefore, Z1 is true for n is equal to 1. Therefore, n is equal to 1. Now assume that 1 is true for n is equal to k.
Okay.
N is equal to k. Therefore, 1 plus 2,
Yes.
3 plus so on, n is less than k.
1 by 8
K. 1 by 8
2k plus 1
k
whole
plus
square
1 whole square.
whole square
Now what we will add in both sides?
K plus 1.
K plus 1. Add k plus 1 to both sides. ਇਹ ਵੀ ਖਾਲੀ ਹੋਇਆ ਵੀ ਮੈਂ ਤਾਂ ਆਪ ਨੂੰ 500 ਕਹਿੰਦਾ ਲਿਆ ਕੇ ਦੇ ਮੈਨੂੰ
ਜਾ ਕੇ ਦਵਾਈ ਫੜ ਲਈ ਨਾਲ ਹੀ ਆਂਦੀ ਤੋੜ ਕੇ ਜਾ ਕੇ ਦੁੱਧ ਪੋ ਜਾਣਾ ਪੁੱਛ ਲਈ ਜੋ ਆਮ ਪੱਕੀਆਂ ਵੀ ਹੋਈਆਂ ਤੇ ਮੇਰੇ ਲੋਸ਼ਨ ਨਹੀਂ ਰਹਿਣਾ
less than 1 over 8
8
k plus 1
2k plus 1 plus 1
K plus 1 whole square
plus
plus K plus 1.
k plus
1.
1. Okay, now solve it. One over 8 into, open this bracket, 4k square plus 2 to 4k plus 1 plus k
8
plus 1. 1 over 8 4k square plus
plus 5k
5k
plus 2
2. Sorry. 1 over 8 is multiplied by first term only, not by k plus 1. Okay. 1 over 8 is multiplied by 2k plus 1, not k by k plus 1.
okay
If we will take 8 as common, then k plus 1 is multiplied with will be
8.
multiplied by 8. Then we can take 1 over 8 as common. Now this will become 1 over 8 4k square plus 4k plus 1 plus 8k plus 8, which is less than 1 over 8
4k square
4k square
plus
plus
12k plus 9.
12k plus 9 less than, we can make its factor 4k square plus
2k
12k plus 9 9 4 का 36
6
6
6
4k square 6k
6k plus 6k
plus 9
plus 9
and 2k is common,
k plus 3
k plus 3 3 is common, 2k plus
2k plus 3
2k plus 3 2k
whole
plus
square
3 2k plus 3 whole square. And we can write it 1 over 8 to k plus 2 plus 1 whole square. 1 over 8, 2 is common, k plus 1 plus 1 square. Compare it with statement. Hence, prove the result. N is replaced by k plus 1. Result is true for n is equal to k plus 1. Compare it with the answer. What is our statement? 2n plus 1. We replace n by k plus 1. Okay. Therefore, result is true. For n is equal to k plus 1. Also, result is true. N is equal to 1. Therefore, by method of induction, true for all n belongs to
belongs to natural number.
natural number n.